Lewis structures can tell you about bonding and how atoms are connected, but they don't really tell you much about the shape, that is, the 3D arrangement of atoms in space. So to talk about the shape and the 3D arrangement of the atoms, we use something called valence shell electron pair repulsion theory, or VSEPR for short. And the key concept is that electron pairs within a molecule are going to repel one another, and the most stable position is when all of the electron pairs are as far apart as possible. And these electron pairs can be lone pairs of electrons, or they can be pairs of electrons that make up different bonds. And the model uses a new phrase called electron domains. And there are two different types of electron domains. They are bonding and non-bonding. So bonding electron domains are any bond, a single bond, a double bond, a triple bond. Each of those would count as a single domain. And any lone pair would also count as a single domain. Electron domains are arranged around a central atom, and they repel each other. And depending on the number of domains you have, you end up with characteristic shapes called electron domain geometries. These geometries are characteristic for a certain number of electron domains, and they provide a baseline for talking about shapes. So we'll look at domains up to 6. So in each of these images, the orange ball represents the central atom, and arranged around that central atom are these bluish-purple lobes that represent electron domains. So we'll start with the case of 2 electron domains, and the easiest way to get 2 things as far away from each other as you can while still being attached to a central point is to have those 2 domains be arranged 180 degrees apart from one another. And the name that we give to this geometry is linear. Everything is aligned in a straight line. And sometimes we refer to electron domain geometries with an abbreviation EDG. And we don't necessarily expect you to draw structures that look like this. A simpler way to draw these things is using what's known as wedge and dash drawing. And to do that, you simply just draw a dot as your central point, or a circle, and then you draw lines representing the electron domains. When you go to 3 electron domains, the easiest way to get them as far apart as possible while still being attached to that central atom is to arrange them in a triangle where each of the domains is 120 degrees apart from the other domains. And the name that we give this shape is trigonal planar. It's trigonal because it's shaped like a triangle, and it's planar because all 3 of those electron domains are in the same plane as one another. They form a flat surface. And the way that you draw that using the wedge and dash diagrams is to draw a dot and then 3 lines. When you go to 4 electron domains, things get a little bit more interesting. The easiest way to arrange 4 things around a central point and get them as far apart as possible is to set up what's known as a tetrahedron, which looks very much like a pyramid. And the angles for a tetrahedron are not as obvious as the linear or trigonal planar angles. These are 109.5 degrees. And to draw this using the wedge and dash diagram is now more interesting. We actually get to use wedges and dashes. So with the wedge and dash system, normal straight lines represent domains that are in the same plane. So the So the up and down and side to side lines represent domains that are in the same plane. Wedges represent domains that are coming effectively out of the screen. So it's a three-dimensional structure. And the dashed lines represent domains that are heading backwards into the screen. When you move to 5 domains, you end up with something that is even more complex. And you end up with 3 of the electron domains arranged in a plane, just like the trigonal planar structure. And those domains are 120 degrees apart from one another. And you can see that in the diagram in the center along the equator. And the other 2 remaining domains are arranged vertically, perpendicular to the plane of the other 3. And those are 90 degrees away from the 3 domains in the central plane. And we give this shape the name Trigonal Bipyramidal. So it's like you have 2 triangular based pyramids stacked on top of one another.